Engineering Eng. PDF document of this video is on engineereng.com.
Hello friends, in this video I want to talk about why it is important to put a period in between while writing equations, when to put it or why to put it. I want to talk about this in this video. As always I say new script. Our aim here is this, guys. While we have an array, this array consists of more than one element. Yes. Our array can be in the form of x equals 1, 2, 3, or x equals minus 5, 0.01 to 5. So this is an array on the first side, like minus 5, minus 4.99, and also 2 goes to 5. And when manipulating these arrays, for example, the graph of y equals to x squared with such an input can be requested, maybe. The first thing we have to pay attention to here is this: the square is important to us. Why? Because the logic of the event here is to multiply x by x. Our goal in multiplying x by x is to multiply mutual x values, that is, the first value to the first value, because I say take one and trade. Therefore, I would like it to process the same number. First, if I get minus 5 for the x value, I want the second to get minus 5 from the x value. Therefore, I have to somehow show that it should take it mutually. Not just for x squared, but for x upper 3 or x upper 4 or etc. Sum goes for. If there is only x, there is no problem, since there is only one array. Or if you multiply x by any number, say 3, it's fine. It automatically multiplies them by 3, no problem. But if x upper 3 means there is a product of more than one array, it's like this. How do we do y multiplies x? Multiply x, multiply x. Before each multiplication, division, exponential operation, friends, this to show the one-to-one product. To summarize that for multiplication, we have to activate it with Shift 3. To summarize for multiplication, division, and exponential and function, you put the sign in front of the as follows. With these, division again, exponential functions, with the signals, you put the sign in front of them as follows. So if it is the product of mutual array, we put that. This is the logic of the event. Now, after explaining this, let's write a few examples if you want. As always, I type my classic comments, and the first thing I will do is write an array like x equals to 1, 2, 3. Let's say you were asked for y equals to x squared. I do this exponential with Shift plus 3. At first it does not appear on the screen, but for example after pressing 2 for the square, use this sign becomes active. The logic of this not being active is because when you put the signal on any letter A, it will be exactly below. It does not appear first, but then it is so that it comes right above A. Now, if you write this like this, y equals to x squared, friends, we'll get an error, because there is x times x. Normally, if I wanted to find 3x, I could type 3 multiply x and find the values. Let's see it. Let's run the program like this. Let's say lesson 14.1. 14.1. Now look, there is no problem in this. Multiply each value by 3. 1 multiply 3, 2 multiply 3, and 3 multiply 3. Let's open it up and see it next time. But what happens when he asks for x squared if he says you that is multiply each term of the x by itself? If you want to see this, friends, you will write either y equals to x dot multiply x. And when you multiply, we got the reciprocal products of 1 multiply equals to 1, 2 multiplies 2, 4, 3 multiplies 3, 9. As another way to do this, I can write x squared too. But this way I get errors. Let's see the error if you want. Our mistake has come. Look here. You counted the matrix dimensions equal. Already here we suggest you put it. Suggest you to put a dot for it. Therefore, we have a dot. We put it like this before this operations. Y equals to x multiplies x dot and square. And now we get x squared the same way as you can see. Let's be an example, guys. For example, let's say you were asked to draw a graph again. Let's draw the parabola. Y equals to x squared if you want. Let's take a look at how we draw it. First of all, write my classic comments quickly. Now here I have created, after this, yes, I have created an x array but has a different definition of array, going from -2 to 2 in 0.01 intervals. In this way, when there is an x array, you should be asked the following question. Let's write the question asked here. Draw the y equals to x squared parabola. Now normally, you know y equals to x squared. Let's draw it this way. What kind of graphic, friends? Y equals to x squared. Here is a graph of y equals to x squared. You know that 1 for 1 for 2, 1 for 2, 0 for 0, and 0 for 0. Yes. 1 for -1, etc. That is the symmetry of the radar with respect to y-axis, so it's a graph like this. Yes. If you are asked to draw this graph now, what should you do? I have defined the range x between -2 and 2, and I equated it to y x squared. Like I said, you can write this as x multiply x, but that if we don't put it, or let's say and comment, you can do it like y equals to x squared. I will do it with both, but the important thing is to have dot before multiply. In other words, because it is a product of array and another array, so that is thus a 1-to-1 product we put dot. This is the logic of the event, okay guys? So this is y equals to x dot. After writing as x the result of y come, and in these y results I say plot newly formed y values for each x value, and let's show this plotting process a little bold. I wrote line width 2, so it draws 2 times bolder. Let's see the lesson 14.2. As you can see, friends, we see this graph that we just drew. You can increase this. Let me increase it quickly for you. Once there is a grid representation like this, we say axis and open it here. We have comment like this: x1, x2, y1, y2. So where does it start? Below. Now let's take a look at what interval we would normally draw the graph at. We plotted between -2 and 2 in x. Let me do it -3 and 3. Let's make y from -5 to 5. Let it appear in -3 to 3 at x. Let me show between -5 and 5 in this. As you can see, this is the graph. So why is the graphic cut off here and does not continue? Of course, the logic of the event is this. I got the x's between -2 and 2, so the value of x is at -2 at the beginning and at 2 at the end. You cannot see the other y values here because I do not give a value less than -2 and greater than 2. If you want to increase the following a little, what you have to do is increase the following a little, like making between -2.5 and 2.5 x equals to -2.5 to 0.01 to 2.5 lines that did not appear just before starting to increase in this way. So graph starts show the value it takes from -2.5. Here, the aim was to see the logic of the event. We have seen we would get an error if we don't use it. Therefore, you can draw the card this way, friends. After seeing that, let's move on to another graph question. Let's do another example for this. Let's get these. They say to you, for example, solve this integral question. Let's say an integral question was asked. They said calculate minus infinite to infinite, integrate a upper minus x square slash square dx. Now guys, it's actually a spatial function. We call this error function, that is error function. The result of this is the difference converged to root 2 multiply p between minus infinite and infinite. Now I know it converges the root 2 multiply p. There's both an integral and expression with x squared here. Therefore, we see that we have to put dot here and we will solve it with two kinds of integral calculus. First, I will solve it with the normal integral command and I will solve it with the traps command. In two different ways, both dot. Let's try to learn how to solve the user with integrals and with traps. Now let's put percentage there first and say let's solve with integral first. Let's say with the integral command we are going to get an integral after all. How are we doing it now, guys? I had to specify with this function in the integral command, the add function. First of all, you can write anything here. For example, let me write question. First, we're putting a @ sign after question. Let's define our variable. Let our variable x be. We were leaving a space. It actually suggests typing fun as default value here, but it doesn't matter what we write. Let's write y. Then I will write the function that I will integrate. The part to be integrated with respect to x is e upper minus x upper 2/2 here. So this is y for us. So I should denote this y as e upper minus x upper 2/2. I wrote it as exp. We will write the exponent of e, so typing exp and opening brackets means write the exponential part. The exponential part is minus x upper 2/2. What are we going to write then, friends? I'm always cautious, and is one of the next video I'm thinking about taking a video title, how to write the long equation without errors. Normally, they show you parentheses and say which parenthesis is closed or not. But I'm going to show you a method that I applied myself. In that method, you won't even need to check these parentheses. I will show you how to properly write equations that seem very long and complex with that method. Now, for example, there's a slash here. Here, do you first multiply the numerator and divide it, and so on. To avoid confusion, as always, I prepare the place where I see slash before I even start writing. Here too I prepared that is divided by 2 after parentheses will be divided by slash. Then I entered minus x squared here like this. Could I explain how I wrote it? So even if I write the division process as always, it is not a problem, but is the most guaranteed way not to get confused by whether we will do multiplication or division first. Look, while I was wandering around it, it comes out of here. I already closed the exponentials, parentheses, but I myself try to write outside the inside in a more assured way. Keep in mind, as I said, I'm thinking of making video after look exercises without errors. Let's come out to question. Let's come to the question. How are we getting integral of this? Let's remember the integral command. We told you in previous videos the logic of the integral of this is this. It takes your function lower limit and upper limit. We have the following command in MATLAB. What have I written here is minus infinite and infinite. How can we define this in MATLAB? You can make a large number like e upper 15 minus e upper 15 endless. This is a method, but MATLAB also provides such a convenience. I write the letter inf of infinite and put minus in the beginning. I represented minus infinite right now. And I also wrote it as positive inf. Now the upper and lower limits are ready. Minus infinite and infinite is ready. My function is ready. Our process of doing the integral with the integral command is ready. I expect it to give me the following result from here. Let's see what happened, guys. What happens, guys? If we don't have any errors, I expect it to calculate it properly. We haven't forgotten our dot. Look here, dot. We have also seen it used. Let's run the program. Let's say lesson 14.3. Look, the result was 2.5066. So what does this mean for us? I told you the result of this equal to 2 multiply p. Now let's see how root 2 multiply p is written in MATLAB. I will now type this in the command window. You are using the lattice sqrt of square root. This means I prepared the root. Now you write whatever is inside the root. Since we can demote p by writing letters, I write 2 multiply p. So how about I do something like this? Since I'm trying to confirm this here, the result 2 multiply p is the result 1 for 1. I told you that is equals to 2.1. I wonder if it's the result in root 2 multiply p. I do something like this to confirm it. I just write squared 2 multiply p here and I say, let's see how close we found it. Look, guys, we see that the result is equal to the function in root 2 multiply p. This is how we solve the answer in root 2 multiply p, which we know readily with some kind of integral operations over less. Now let's solve this with traps, guys. Now I get this right now into my new script file. Let's remember traps. The integral command is giving the upper and lower limits. It never looks between. It gives us the result by calculating it directly in terms of lower and upper limits. But if you recall that there was a logic in traps, let our integral stay on the screen. It takes something like this into traps. Look, this is the logic of traps. It takes an array into traps. This takes the function with respect to array or the integral of the element we call y. So what is the array? What array is it, friends? That array that is formed from minus infinite and plus infinite. There are steps here. Our steps are clear. The steps are not clear in integral command. It only operates according to upper limit and lower limit. For the traps command, let's say, for example, an array like minus infinite to plus infinite in the all steps. Let's have a try. In 0.01 steps, let's have a try again. So divide the intervals with 0.01 intervals. Look at these integral steps according. It was a command like the integral of the function. So now I will follow a different method this time and do something like this. I will say that my aim is to compute the integral of e upper minus x upper 2/2 between minus infinite and infinite with fraps. So I'm creating one x array, let it be between minus 10 and 10 with an interval of 0.01. Now I will give a numerical value to take them to infinite a little later. I will then see if I can approach the error function. The error function tells me the further you take the upper and lower limits from each other. So if you move the left one to minus infinite and right one to infinite, the answer says 2 multiply p. I want to see this now. The traps function says apply as follows to me. Take the x array, so I have taken the path where the upper and lower limit is now from minus 10 to 10. There's an x array that goes from minus 10 to 10 in 0.01 steps. We write x and function is the traps function. Let's say y instead of function. It doesn't matter what the name is. Now I want to check if it will come close to in root 2 multiply p again. You don't need to use @ sign here because our array and a function are certain. Let's close this so the process doesn't take long. Keep in mind. Let's close. The process doesn't take long. Keep in mind. You can turn it off with this. Let's calculate with the common traps and see. Because our array function are certain, I say that before. Let's close that too soon, then process doesn't take long again. Keep in mind with this signal, you can turn it off. Let's calculate with common traps and see if our result will come close to in root 2 multiply x. Now I ran the program. Such an erroneous result came. Let's take a look why it came like this. Of course it sounds like this because we forgot we write minus x squared. Otherwise the number went towards infinite. Let's run it again. As you can see, we again found the answer in root 2 multiply p, which is our error function. Let's remember what was in root 2 multiply 2. As you can see, we found the same result. What would happen if I made the boundaries a little smaller from minus 3 to 3? Then the result would be slightly smaller than the answer, 2.5066. It would be 2.4999. For example, let me, if I can use inf here, but I think we can add something to infinity and never increase it and reach infinity. In my opinion. Let's see if he assigned a numerical value to himself. As you can see, I got an error. Since I got an error, we can use 1000 instead of infinite here. It's already gave the answer at 10. Let's say from minus 1000 to 1000. Yes, this is more guaranteed weight. As you can see, we reached the answer in root 2 multiply p to 2.5066 again. Finally, here is one more thing I want to mention. A question may arise about what if I use is not needed, nothing happens. Let's show that. For example, let's say a square t 2 multiply p. There was no result in this. See dot before all multiplication, division or exponential function, it doesn't change anything. Because I was habitual after a while everywhere that I was putting. This gave me a guarantee in the process because the question I solved were usually very long questions. For example, let me show you one of these long equations. Such long equations, etc. was happening. Quite a lot of dot need to use. Everywhere dot I was putting. But you might say that I always say dot, let me put, but there comes a moment when dot is regretted putting it on. Not that it will be a problem for you right now, but you can take an equation from MATLAB to transfer it and it to another program. For example, there is a program called AWR, Microwave Office. You can write equations here. As I was saying, I don't use Simulink. This AWR program is similar to Simulink and much better than Simulink. You can write equations there again. When you write the equation, for example, it does not accept dot. There was trouble there. I just said trouble here. If you are only going to process a MATLAB dot, there is no harm in putting it. As I say dot, if you use it, there is no problem before this multiplication, division or exponential sign. No problem. Hope to meet you in another video. Goodbye.